Let's look at cylinder blocks. The cylinder block is the largest part of the engine. Its upper section carries the cylinders and pistons. Normally, the lower section forms the crankcase and supports the crankshaft. It can be cast in one piece from grey iron, or it can be alloyed with other metals like nickel or chromium. The iron casting process begins by making up the shapes of what will become water jackets and cylinders as sand cores, which are fitted into moulds. This stops these parts becoming solid iron during casting. Molten iron is poured into sand moulds that are formed by patterns in the shape of the block. After casting, core sand is removed through holes in the sides and ends, leaving spaces for the cooling and lubricant passages. These holes are sealed with core or Welsh plugs. The casting is then machined. Cylinders are bored and finished, surfaces smoothed, holes drilled and threads cut. All cylinder blocks are made with ribs, webs and fillets to provide rigidity, but also to keep weight to a minimum. As more manufacturers try to make vehicles lighter and more fuel efficient, more and more engine blocks are being cast from aluminium. A block made of aluminium alloy is lighter than if it were made of cast iron. So if two engines are generating the same power, the alloy version would have a better weight to power ratio than the cast iron version. Aluminium alloy blocks are made by various casting processes, including pressure casting. Another method is gravity casting, where the molten metal is poured into moulds. Cast iron liners are usually used in the cylinders of aluminium blocks, and sometimes in cast iron blocks. Some sleeves are cast into the block. Grooves on the outside form a key that stops any movement in the cylinder. They also increase the surface area to assist heat transfer from the sleeve to the block. Some blocks don't need liners. They can be made of wear-resistant material that makes a hard-wearing surface for the pistons and piston rings. Or the cylinder bore may have some sort of surface treatment to make it hard-wearing. When the cylinders, block and crankcase are all cast together, it's called a monoblock construction. This is called a horizontally opposed block. It has a split crankcase. The two engine blocks are joined together by the flanges of the crankcase. In air-cooled engines, the cylinders are usually made as separate parts, then bolted to the same crankcase. Each cylinder has cooling fins. They're often machined to give uniform thickness and allow free flow of air. Let's look at cylinder sleeves. Cylinder sleeves are used in engine blocks to provide a hard-wearing material for pistons and piston rings. The block can be made of one kind of iron that's light and easy to cast, while the sleeve uses another kind that is better able to stand up to wear and tear. There are three main types of sleeves: dry, flanged dry, and wet. The dry sleeve can be cast in or pressed into a new block, or used to recondition badly worn or damaged cylinders that can't easily be rebored. It's a pressed fit in its bore in the cylinder block. Its wall is about 2 millimeters thick. Its outer surface is in contact with the block for its full length. Its top finishes flush with the top of the block and can hardly be seen. Once in place, dry sleeves become a permanent part of the cylinder block. A flanged dry sleeve is like a normal dry sleeve, but a flange at the top fits into a recess in the surface of the engine block. It's not a tight fit, and it can be replaced if it's worn. With a wet sleeve, the outer surface is part of the water jacket around the cylinder. It's called wet because it has coolant against its outer surface. This helps speed up heat transfer between the sleeve and coolant. The sleeve is sealed at the top to prevent coolant leaks. This stops coolant entering the combustion chamber and the bottom of the crankcase. A flange at the top of the sleeve fits into a recess in the block. The lower end has 1 or 2 neoprene sealing rings. With coolant in direct contact with the cylinder sleeve, corrosion can be a problem. It can even insulate the sleeve from the coolant, which reduces the main advantage of having a wet sleeve at all. The walls on wet sleeves are thicker than on dry sleeves. They don't have the same support from the block as dry sleeves, so they depend on their wall thickness to stop distortion. In diesel engines, vibration caused by combustion can cause cavitation. This damage appears similar to corrosion, and it can eventually destroy the cylinder.